Okay, hi everyone. So in this video, I will explain about uh, heterogeneous catalysis, and one of important step in it is the adsorption. So let's start. So before we enter the heterogeneous catalysis, so I will explain what is catalysis. So catalysis is the process of increasing the rate of chemical reaction by adding a substance known as a catalyst. So this catalyst is not consumed in the reaction, uh, and need very small amount of catalyst to alter direction. So this is a good thing in the chemical reaction. So heterogeneous catalysis is the type of catalysis where the phase of the catalyst differ from the phase of the reactant or product. So it's the opposite from the homogeneous catalysis, where the reactant, product, and catalyst exist in the same place. So you can imagine this is a reaction with a different phase, maybe solid liquid, solid gas, etc. And also uh, with immiscible mixture. Example is oil and water. So if you see the miscible reaction is like water and ethanol, so they mix well. So heterogeneous catalysis also happen in immiscible mixture, so the mixture did not mix. Heterogeneous catalysis typically involve solid phase catalyst and gas phase reactant. So in this case, there is a cycle of molecular adsorption, reaction, and desorption occurring at the catalyst surface. Thermodynamics, mass transfer, and heat transfer influence the rate of kinetic of reaction. So rate of reaction is the speed at which reactant are converted into product. This is for the example, just like the oxidative roasting of iron. It's a slow reaction. It can take many years, but the combustion of the cellulose in fire is a very quick reaction, and it can happen in a second. Heterogeneous catalysis is very important because it enables faster large scale production and the selective product information. So it said approximately 35% of the world's GDP is influenced by the catalyst. The production of 90% of chemicals is assisted by solid catalysts. The chemical and energy industries rely heavily on heterogeneous catalysis. This, for the examples, is this is very famous process, the Haber-Bosch process. Use metal-based catalysts in the synthesis of ammonia. Ammonia is very important component in fertilizer. So 140 million tons of ammonia. This is produced in 2016. This is the picture how the hydrogenation of ethane in catalytic solid. So you can see in the picture one, this is the adsorption process, and number two picture, this is the reaction process. The number three is a desorption. You can see the adsorbate is moved out from the surface. Now we will talk about the adsorption. Why adsorption? Because this is the important step in the heterogeneous catalysis process. So, adsorption is a process by which a gas or solution binds to solid or liquid surface atoms. The reverse of adsorption is desorption, the adsorbate splitting from adsorbent. In the reaction facilitated by heterogeneous catalysis, the catalyst once again is the adsorbent, and the reactants are the adsorbate. So adsorption is the addition adsorption is the addition of ions or molecule from a gas, liquid, or dissolved solid to a surface. So addition is a the tendency of dissimilar particle or surface to cling one another. So it's like a link together. The process creates a film of the adsorbate on the surface of the adsorbent. So it's like a thin layer. This process differs from absorption, in which a fluid is dissolved by or permeate a liquid or solid respectively. So there are two kind of absorption. This one, adsorption, is use delta, A delta, and then the other one is absorption, so alpha, bravo. So this is the same the same absorption process but different system. Adsorption is a surface phenomenon, while absorption involves the whole volume of the material. The term absorption encompasses both processes, while the absorption is the reverse of it. So either it is adsorption or absorption. It can happen, become the desorption process, where the adsorbent is out from the adsorbent. Okay, so actually, adsorption is similar to surface tension. So surface tension is the tendency of liquid surface to shrink into minimum surface area possible. So the example is like you guys maybe see insect that walk in the water, and then they float, like walk in the water. So this is the example of the surface tension. The adsorption is a consequence of surface energy in a bulk material, or the bonding requirement, be they ionic, covalent, or metallic, of the constituent atom of the material are filled by other atoms in the material. However, atoms on the surface of the adsorbent are not wholly surrounded by other adsorbing atoms, and therefore can attract adsorbents. The exact nature of the bonding depends on the detail of the species involved, but the adsorption process is generally classified as a physisorption, also called physical adsorption, is process which the electronic structure of the atom or molecule is rarely perturbed upon adsorption. The characteristics is the this is the weak sorption. So the characteristic is this is using van der Waal process. So this is the Dutch scientist, and the other adsorption is a chemisorption. So this is the characteristic of covalent bonding. So it is more stronger than the physisorption. So chemisorption, kind of adsorption which involves a chemical reaction between the surface and the adsorbate. So new chemical bonds generated at the adsorbent surface. For the example is include microscopic phenomena that can very be obvious, like a corrosion. Yes, corrosion is a example of the chemisorption, and the subtle effect associated with the heterogen. Adsorption is present in many natural, physical, biological, and chemical systems, and widely used in industrial applications such as heterogeneous catalysis. So heterogeneous catalyst, the type of catalyst where the pass, once again, I will repeat it. So heterogeneous catalysis is the type of the catalysis where the pace of the catalyst differ from the pace of the reaction or the product. Also, another one said from industry applications, activated carbon or activated charcoal is a form of carbon processed to have small or low volume pore that increase the surface area available for adsorption or chemical reaction. So activated is sometimes substituted with the word active. Capturing and using waste heat to provide cold water for air conditioning and other process requirements. So waste heat is heat that is produced by a machine or other process that use energy as byproduct of doing work. So all such process give off some waste heat as a fundamental result of the laws of the thermodynamics. Waste heat has lower utility than the original energy source. Increasing storage of capacity of carbide derived carbon. Carbon derived carbon, also known as the CDC and also known as the tunable nanoporous carbon, is the common term for carbon material derived from carbide process. And then for water purification, this is widely used for the adsorption. Water purification is a process of removing undesirable chemical, biological contaminants, suspended solid, and gases from water. The goal from water purification is to produce water fit for specific purpose. So there are some requirement for water, just like a type of water. So there are ISTM1, ISTM type 2, ISTM type 3, RO, uh, etc. So the adsorption, ion exchange, and chromatography are sorption processes in which certain adsorbate are selectively transferred from the fluid phase to the surface of insoluble liquid particle suspense in the vessel or packed in column. Pharmaceutical industry application which use adsorption as a means to prolong neurological exposure to specific drug or part thereof lesser known. So lesser known for the pharmaceutical industry. So we will talk about the type of the adsorption. Two type of adsorption are recognized as we talked before. Physisorption is a weakly bound adsorption, and chemisorption, strongly bound adsorption. So in physisorption, a molecule become attract to surface via van der Waals. This include dipole-dipole interaction, induced dipole interaction, and London dispersion force. Note that no chemical bonds are formed between adsorbate and adsorbent. So note that no chemical bonds are formed between adsorbate and adsorbate, and their electronic state remain relatively unperturbed. So the typical energy for physisorption are from 3 to 10 kilocalories per mole. In heterogeneous catalysis, when a reactant molecule physisorb to a catalyst, it's commonly said to be in a precursor state, an intermediate energy state before chemisorption. So this is before the chemical substance state. A more strongly bound a more strongly bound adsorption. From the precursor state, a molecule can either undergo chemisorption, desorption, or migration. So we note this. So from the precursor state, a molecule can either undergo chemisorption, desorption, or migration across the surface. The nature of the precursor state can influence the reaction kinetics. The other one is the chemisorption. When a molecule approaches close enough to surface atoms such that their electron cloud overlap, chemisorption can occur. So electron cloud is in the atomic theory and quantum mechanics an atomic orbital. So it's a mathematical function that describes that wave-like behavior of either one electron or a paired electron in the atom. So this function can be used to calculate the probability of finding an electron of an atom in a specific region in atoms. In chemosorption, the adsorbate and adsorbent share electrons signifying to the formation of the chemical bonds. So it's a lasting attraction between atoms, ions or molecules that enable The formation of chemical compound. The bond may result from the electrostatic force of attraction between oppositely charged ions, as in ion bonds or through the sharing of electron. The typical energies for the chemisoption range from 20 to 100 kilocalorie per mole. So you can see from the energy, the physical sorption, or we call it physisorption and chemisoption, is different. Chemisoption has a higher energy than the physisorption. So logically, the chemisoption is stronger. The bond is stronger than the physisorption. So the the contact, the bind between the adsorbent and the adsorbate is stronger than the physisorption. So the example of chemisoption are the molecular adsorption and then the association adsorption. Okay, thank you. I hope you guys understand what I'm saying. Thank you. Bye bye.